Welcome students to part 3. We're going to continue. We reach number 3 and we solve for Z in, you can check the previous video part 2. Let us continue. Here the question is find x and y so that x plus I square equal to minus 4i. I need to find x and y. So I expand a plus b square is a square plus 2ib plus b square I square y square which is minus y square equal to minus 4i. We said two complex numbers are equal when real equal real, x square minus y square equal to 2. Imaginary coefficient of I, 2xy equal to minus 4. So I have a system now. It's an ordinary. You did it before. Don't forget that x and y must be real. This is the property of the complex when we started. X and y are real, cannot be other than real. So if you get y is minus 2 over x and you replace it up, you're going to get this equation, y squared, so it will be 4 over x squared. Same denominator or multiply all by x squared. So x4 minus 4x squared over x squared cancel. Minus 4 equal to x squared. I have an equation of second degree, but the second degree can be reduced to second degree where x4 minus 2x squared minus 4. So if I do delta, I'm going to get 20 b squared 4 minus 4ac is 20. Instead of writing x, I write x squared because it's in x squared, can be reduced. I have two roots, minus b plus radical delta over 2a. I have 1 plus radical 5 and square equal minus 1 minus radical 5. But I said before x must be real. So this is square equal negative. It's impossible. So I take the first one. X squared equal 1 plus radical 5. If I get rid of the square, I have a plus or minus square root 1 plus radical 5. Now, if x equals square root 1 plus 1 plus radical 5, if I replace it here, I get minus 2y over square root 1 plus radical 5. And if x is minus, I'm going to get this one. Properties. Always, like we did in before, if a plus root b is a root, its conjugate a minus root b is a root. We know in second degree equation. X1 equal minus b plus radical delta over 2a. 1 is minus, 1 is a plus, a plus b plus radical delta over 2a. And similarly in complex number, if a plus I root b is a root, then a minus I root b is also a root. What is the importance of this thing? Suppose I said write a polynomial whose roots are 2 minus radical 3, 2 minus I. First of all, if x equal to 2 is a root, it's obligatory, so the factor will be x minus 2. But if minus radical 3 is a root, also its conjugate must also be a root. So I have here two factors, x plus radical 3 and x minus radical 3. If x equal to minus I is also a root of that polynomial, 100% we must have its conjugate 2 plus I. So you're going to get x minus 2 plus I, a root and a factor, and x minus 2 minus I is a factor. Let us take more example. Here I have roots, write a polynomial given these roots. 0, yani x minus 0 is a factor, yani x is a factor. If 2 minus radical 3 is a root, 2 plus radical 3 should be a root. So these are the two factors if you bring these two to the first side. And if x equal 3i is a factor, its conjugate must also be a factor. So it will be x minus 3i into x plus 3i. Let us do the vice versa. Now I gave you a polynomial of degree 4. I gave you one of the root. You must find all the other. So we know from before, if x equal to minus I is a root, then its conjugate should be a root. So we take this product, x minus 2 plus I into x minus 2 minus I. We multiply it together. So x squared minus 2x minus ix minus 2x plus 4 plus 2i plus ix minus 2i minus I squared, which is plus 1. You're going to get at the end this one. Now, this is a factor. So what do? We do ordinary division. We take this one. We divide it by x squared minus 4x plus 5. 2x4 divided by x squared is 2x squared. We multiply and you put opposite sign. So 2x4 opposite sign minus 2x4. 2x squared times minus 4x is minus 8x cubed, opposite sign 8x cubed. 2x squared times 5 is 10x squared, opposite sign. These two cancel out and remain with minus x cubed plus 3x squared minus x minus 5. Minus x cubed divided by x squared is minus x. If you multiply on the opposite sign, you're going to get here minus x cube will be x cube, plus 4x squared will be minus 4x squared, minus 5x plus 5x. These two cancel out. I'm left with minus x squared plus 4x minus 5. Minus x squared divided by x squared is minus 1. If you multiply at the end, you're going to get 0. It means what I did up, the product was correct. So what is the second factor? The second factor will be 2x squared minus x minus 1. You all know this is an equation of second degree. I can factorize it very easy. I do delta. If you do delta, b squared minus 4ac. B squared is 1 plus 8 is 9. I have two roots. One of the root is 1 and the other root is minus half. So the factors will be x minus 2 plus I into x minus 2 minus I into x minus 1 into x plus half. But don't forget, like I did now this mistake, you must put coefficient of x4 in factor. What is the coefficient of x4 here, which is a in general 2? So you must have here 2 into these two. Another example, last example, suppose I want to factorize. Here I gave you radical 2. If x equal radical 2, also x equal minus radical 2 is a root. So x minus radical 2 is a factor, x plus radical 2. If you do it a minus b into a plus b, x squared minus 2. So if you divide this whole thing by x minus 2, you can pause the video and check that this is all correct. This will be the factor, the other factor, x squared plus 2x plus 2. This is an equation of second degree. If I do delta, b squared is 4 minus 8, so minus 4, so I have two complex root. If you do minus b, which is minus 2, plus or minus radical minus 4 over 2a, which is 2, you're going to get these two roots. You can check it, you can solve it by yourself and check this. This is the answer. You have two roots, minus 1 plus I and minus 1 minus I. So if I want to factorize it, I have, as I said, x minus radical 2 into x plus radical 2. If you bring this to the first side, you're going to get x plus 1 minus I. And if you bring this one to that side, x plus 1 plus I. This is the third part of the video. I hope that you enjoyed the lesson. And we're going to continue in another videos concerning the complex. Thank you, grade 11 students. Hope that you got the first part of the complex number. As you saw, it's very simple, very easy. We need to work and check always our work. It's all properties, you have it in these 3 videos. So I want you to review it and watch it more than one time. Thank you for listening and see you in school in class.